Hey guys, and welcome back to another episode of Retro Recycling. And yes, I have a jingle finally. Um, Today, since I don't really have too much to do, we are going to be looking at um a guide on Extended Color BASIC. I'll show you how to get started. So first, you're obviously gonna want to write now. Well, it's not obvious. And I'm gonna type in the list command, which will list all the program. We see nothing. First I'm gonna type CLS, which clears the screen. I believe it's is short for close. And yeah, type list. There's nothing there. So we have a fresh program. What do we want to do with it? Well, we're gonna start with the basics. So let's type in 10. Now, this is telling our computer that we want to enter a new line. Which line? Line number 10. That's what we enter. You can start at 1 and do 2, 3. Actually, I believe the first line you can do is 0. And then you can do like this. But most people, they do 10, 20, 30. And the reason is because look, if I do 1, this is just an example, and then 2 print 3, I can run that. 1, 3. But I forgot 2. There's nothing in between 2, so I have to assign that to 3. Now it works. But if I do 10 print 1, 20 print 3. Now look, there's a lot of numbers in between 10, so I can do like 19 print 2. It works. So that's why many people decide to print in tens, and a lot of people print in hundreds. I started learning using hundreds. So then you have like a bunch of space. Like if you want to add, like if you're programming a game, it's best to stick with tens and hundreds, but I often break that rule a bit myself, and do like ones, and sometimes I'll do like 10, 17, 16, just random stuff. Um, but, for like a game, say you, have like 10 just random enemy, pause, 2 sprites. You can't, I don't think you can really do sprites. I'm just giving like a random example. And then say I want to add some kind of like goal to the game or win thing. I can print, I can do 150, or like I have a bunch of ones. Now I can do you win. You have won today. You have won. Lost. Now, of course, if I run it, it says syntax error because enemy pause and sprites aren't even commands. Even in extended basic. But yeah. So I'll put that right. All right. So what are we gonna put on line 10? Well, most people start by putting the words "Hello World" onto their computer screens. That's what most people. Now, how do we do that? Do we just type "Say Hello World"? I mean, that seems right. No, say hi. Okay, so say is not a command. We will type 10 again, to clear line 10. Now, what do we need to do to tell the computer we want it to like put something on the screen? There's a word for that. Maybe it's print. Let's try that. Print hi. Okay, it did it, but it says 0. Interesting. Well, I'll tell you what's wrong. Well, actually, can you guess what's wrong? Put it in the comments or whatever you want to do. Or just shout at me through the screen. I don't know. But I will tell you. when you put print high, it thinks high is a variable. Let me show you this. I will do 9, and we're going to say high equals 1. This is just saying variable high to 1. Now, by standard, most variables are 1 or 2 letters. If they're 3 letters, that either means you have a $sign, which means string, which we'll get to later, or it will normally ignore all the letters after that. So we can run that, and now it says 1. So yeah, we know that is a problem, and that's what it's trying to do. It's looking for the variable high. Now, when you type print something, if you type print, it will automatically switch to a numerical mode. So if I do print 1 plus 1, it will do 2. Print 55, let's do times 7. There. Now, this, I just did that in direct mode, which just allows you to do those functions without adding a program line. So you see we have no program. Oops. So we are going to make our program, and now since we don't want it to like do math or print a number, and so if you do it outside, so you need to do quotation marks. So if you do it outside the quotation marks, it treats that as a number, or some kind of numerical value or problem, or like math equations, stuff like that. Now, this is very useful for later because, as you see, it's printing the variable high, because when it's in numerical mode or outside of the quotation marks, if you put any text in it, it will automatically assume it's some sort of variable. So this is handy for doing like algebra or some games, and anything you want to print the value of a variable onto the screen. You can do that with this too. It's not just, but it is mainly like numbers. So, now you can do print high string, which again we will get to string variables later. We aren't even in that part. But you will print. So maybe we want So we're gonna print high in quotation marks. Now these quotation marks are telling the computer, hey, this is a string. Again, we'll get to string. Well, actually, I'll explain what a string is. A string is when you put something in quotation marks, it's considered a string. Now strings are basically big bunches of text that can be however long you like, unless it's not like in a character limit or whatever the computer has to deal with it. Now, when you put something in quotation marks for these commands, normally it will treat it as a string. And if it's a string, the computer will know, hey, he wants this text displayed on the screen. And for other things, it just signifies that it's like text or something. So you can't type. So if you try to assign text to something or use text with a command without the quotation marks, again, it will treat it as like numbers or variables. You have to put it in quotation marks to tell the computer this is like information with text, not like, and should not be treated as like mathematical stuff. So now this will just return the word high. Now I said hello world, not hi, so we will do 10 print hello world. This is standard. We can list that. And you've done your first program. Congratulations. Now, a lot of people's next step is, well, what if I want it to like repeat a bunch on the screen? Well, you can actually do that. Let's start at line 20. Well, let's do 11. Actually, let's do 20. There's actually a very useful command called go to. Now, make sure, I believe I think, well, I'll try it. Oh, it does work. Okay, well, normally you put go to in one single word, but I didn't know you could do that. But how do we get it to the beginning? Well, you see, since it's line 10, we will type in 10. This is telling the computer to stop and go back to line 10 and execute that again. So as you see, now it looks like it's just all on the screen, but it's actually scrolling. It's just really fast. See, I can put line 15. Now we will get into for loops later, but whatever. But this basically for now I'll just say this basically makes a short pause. Now we will see it keeps printing them. Now a simple way to show this is we will do 10 print line 10, 15 print line line, and we can do this which basically will print line 15. It does the same thing. It's just out of brackets because this time we are treating it as numerical values, but since it's not math, it will still print it exactly like that. Now we'll do print line 20, line 20 go to command or something like that, and then we will do a colon go to head. Now that colon signifies that you want to do multiple commands in one line. So basically it's the same effect of having them in separate lines, but they're on one line, so it saves space and stuff like that. Now we will run this. Now that's super fast. So 15 print line 15 and we'll just do that same for loop. Next. Okay. So yeah, we can have multiple. So now you see you kind of have a good visualization of how this program will work. Now let's get started on something you can actually do that's fun. Let's explore the sound command. So, well, first we'll actually explain for loops. So basically, a for loop, you type in for, you type in a variable you can assign this to, but it has to be like numerical. So we can do anything. We can do LK, LJ, SS, whatever, AB, AC, DC, DA, DB, whatever. So but normally you do I is the most common variable for this. Now we've put an equal sign. So basically we're gonna do 1 to 100. Now this basically makes your it's just like the go to command where it is called a loop, where it goes in loops. Kind of like if you have a hula hoop, it comes around, it um it spins, but it keeps spinning on forever, or until you stop spinning the hula hoop. It's just loops are just like that. They exit on computers. They execute a few things, and when encountering a loop command, or like a loop ender or a go to command or whatever, it will return the computer's, I guess you could call it a pointer, that's currently set to whatever line that ending loop part is, back to whatever line you specify. I know that's confusing, so but if we print something on line 10 and we have a go to loop at line 20, and we specify go to line 10, it's basically going to execute line 10, move forward to line 20. Now the pointer is like, oh yes, this is a go to command. What line is it? Oh, line 10. And it moves backwards to line 10, and it just goes on forever. But for when you use a for loop, it keeps track of how many times it's executed the loop, of course using variables and such. So it will basically create a limited loop where it only runs for a certain amount of times. Now we want it to run for 100 times now. So this one command is basically telling the computer we're counting from 1 to 100. Now we're gonna insert a line 20. Now, you don't have to use colons for this. You don't have to keep it the same line to make it a loop. Anything that is in between this for command on line 10 and the next command, which will close the loop, which we'll get to in a second, will be executed within the loop. So we're gonna print hi, this is loop, and we're gonna actually put I, so it will tell us what number we're on. And 30, next I. So this is telling the computer to do a loop. We're first assigning how the variable and how many loops. Now 20, we're doing a command within the loop. 30, we are finishing the loop with the next I, which will return it back, but it will also increase the variable by 1 or whatever. So continuing the loop. Now we will do this. And now it has executed. Now this is a bit tricky to see since it's so fast, but let's do 10. So yes, that is how for loops work. And we can remove line 20, and you see it's so short because it has nothing to do. But remember when we did that earlier, and I put a really big value like 700, and it waited for a tiny bit. Now, or a good bit. Well, that is basically sending it on a loop that many times. And it's counting that many times, but it's not doing anything during that, so it kind of creates a pause where the program is not doing anything. Now we can do this. We can pen for I equals, let's do 1 to 247 or something like that. Now 20, we're going to use the sound command. Like I said, the sound command has two things. It has tone, comma, and then duration or length. So if you type in the sound command, you type in a number between 1 and 255, and that's the tone, or what it's most commonly called. And after the comma, you put a number, which is how long it will take. So it's basically like having a for loop that every iteration it beeps, but it continues beeping for that amount, and then when that loop is done, it stops. But it's all in one command, and so basically we're going to do I, and then I, well, not, that's a good start, and then next I. Take a long time, so we will make 20 sound I 1. That's the shortest it can be. Now that seems pretty long. But we can actually do something cool. So we're gonna do for I, well, this time we're gonna do A. A equals 1 to 2, 20 for B equals 1 to 2. Now you might think this is a typo. Well, actually, this is called nesting, where we will be adding, we can add a loop inside a loop. So we can show this off by sound B plus 200, 3, 26 we will do next B, 30 we will do, sound, like 176 or something like that for 2, 31 next A. Now it can't be next A, next B, because that will be an error, because it's like the other way around. See, line 10 connects to line 31 because we're executing those things in that loop. Line 20 connects to line 26. That's the correct way. So now we will run it. So you see, we're gonna actually enter something. See, this is useful. Print B, and 11 or whatever we print A. Well, actually, we'll just do it when we do the sound. So like this, print A, and we will make it simple, because we will this. So now you see, we can do 10 for A equals 1 to 9. So this basically, this is pretty much all you need to know for now about nesting. Now, what we need to do is I'll combine these things and make a game. Now, I'll make a short game. So 10, we will, well, first we'll do for, so I'm gonna actually try to make a game where, it's similar to another game I made, but it's kind of the opposite. But I don't know, it's gonna be a little more complex. So basically, we're gonna have apples, and you're a bucket, and you have to move, in like X positions, and catch all of the apples. We will have like a score. If you manage to catch one of the apples, it will increase by I guess 1, and if you fail to catch one, it will decrease by 1. Now we'll do for apple AY, which is going to be apple Y, or let's just do OY for object Y, and for object Y equals 0 to let's do 6, so they won't fall from that great of a distance. 20, print. Now we're gonna use print and then the @ symbol. This is gonna be this is just putting it on a position on the screen. Now actually we will do 10 for OY equals 0 to, let's do 600, and then we will type, well actually let's do 270, step 32. Now what that does is instead of increasing the counter by 1 every loop iteration, it will increase the variable counter by 32. Now this is very useful for our program because the screen is 32 characters long, so this will be so this effectively will to whatever, I guess 270. Let's actually do that. 270 divided by 32. That is about, let's actually do something better. 260 divided by 32. No, print 250 divided by 32. No, print 236 divided by 32. No, print 238 divided by 2. No, print 230 divided by 32. Okay, print 240 divided by 32. Okay, print 241 divided by 32. No, print 239 divided by 239 divided by 32. Print 235 divided by 32. Wow. And this is our 230 divided by 32. So print 228 divided by 32. Oh man, this is hard. Print 220 divided by 32. Okay, we're getting close. 222 divided by 32. Oh, print 223 divided by 32. Print 224 divided by 32. Okay, so 224 is 7 lines. OY equals 0 to 224 step 32. So this is going to do a loop for effectively 7 lines of the screen. Now it's 7 lines of the screen. We have to print something. So again, we'll do print at let's do OY we'll do OY or whatever, and we'll do plus we'll do R, which will be a random like X position. Now we will do this in a second. We're gonna do a comma, which will which is we're just telling the computer what to print. So what's a good example? We'll just do an O. Now we're gonna do this in line 15 or 16. 15 R equals R and D, and we're gonna do 7. And 30 next OY. Let's see what this does. Oh, okay. So first for line 11, we're gonna clear the screen. Oh, that does something. Okay, now we of course I'm gonna actually make this super late so we have room. For K equals 1, or just like W for waiting or something, or like time. I don't know. W equals 1, 2, let's do like 993 for now. Like 81 next OY. Okay, that is not working. Oh yeah, because we did do a next. See, if you don't put a next, it won't do a syntax error. It will just it will just not, work right. It just won't do the loop. Okay, that is way too long. 84 W equals 1, 2, 1, 2, 1, next. Okay, that's actually perfect. So now we have the apple falling. Now we want to print the player to the screen. Now how are we going to do that? I'm going to add a line 21. We're going to print, again, at, and we're going to make, let's say, 224, times 32. Now actually, this is handy. What is 224 times, or I mean divided by 32? I don't know. Print 224 divided by 32. No. Actually, no, I think we've got it right. I think I was thinking about another program where I had to do, I don't know, 224 actually, yes. 224 plus, x plus 1. Or we'll just do 225 plus, px or x. Let's just do x, or maybe ux for user x. And we will print like a lovely, what can we do? Oh yeah, that's not a valid thing. We'll do, can't think of something that looks like a bowl. I guess I can do like, I'll just do like that. It's fine. Okay. Alright. Well, that's good. Now in, let's go line 16, we're going to, we're going to assign the variable string. Again, remember, strings are in quotation marks. They're basically text and stuff, and they won't be treated as mathematical operations or anything. K equals in key. Now, this will assign the variable string to in key, which in key stands for, it's like a command. It's the command that grabs whatever key you're pressing currently, and we'll assign that to the string variable. Now, you can't use in key on its own. I believe you have to use it in a variable, because I've tried. It doesn't really work. So we're gonna do this at like line 18, 17, no, 17. Keep it nice and close. If k string equals, for my previous things I've been doing like 1 and stuff, x equals x minus 1. 18 if k string equals 2, x equals x plus 1. And remember, we have to have it in quotation marks. So if we push the 1 and 2 keys, it will move it left and right. Now we're going to add some checks to make sure it doesn't go too far. If k string, if x is less than 0, then x equals 0. We're going to use a handy colon to keep it in one. If x, and we can bunch them together, but I'm not going to do that. If x is greater than, I guess, 7, then x equals 7. Oh, syntax error in 17. Oh, it's because we forgot the then. Then is an important thing. Oh yeah, I forgot to explain if statements. Well, they're exactly how they sound. An if statement checks if the value of a variable that you have to enter um is more than um right. The if statement checks that a variable it's basically a comparison between the variable you enter and another value you enter, and if that value is assigned to the correct assigned to the variable you enter, or if the variable has that value, it will execute the command after the word then. Else, it moves on to the next line. So all we're really doing here. Oh yeah, I got confused. Okay, so basically all we're doing so it's basically checking if one value is equal to another. Now um this thing that says k equals k minus 1, k is k plus 1, it's setting the variable k, or I mean x, not k, x, to this value that we're entering. Now the value we're entering is the variable x, so what it's currently at, subtract 1. So basically if x is at 7 when this command, when the 1 key is pressed, it will take x, set it to x, which is currently 7, and subtract 1. So the x is now 6. So you can look. Actually, I'll set the for w equals 1, 2, 3, 4, 4, 2, 1. Next. So we can move. Huh? What? Oh yeah, we did ux, not x. I forgot. Okay, so this is an easy fix. Simple, pretty simple. On other computers, you can just go back live on a Commodore computer, on the Commodore computers and stuff. You can use the arrow keys, which are actually really weird, to just it's kind of like a text editor where you use the arrow keys and you go back and you can overwrite something. That's actually when they actually use the insert key. It's the only time in my life I use the insert key. But yeah, alright, this should work. Yay, it's working! Oh god. Oh, did I catch it? I don't know. 15R equals RD. We're gonna make this simpler. 19 if x is... See, this is the thing, but this is, again, because oh yeah, because I can't, now I still have, actually would have to get it, but I have to now, um, do all of these lines, so if it's a big one, it's like a bunch of lines combined, you have to rewrite practically the whole program, which, well, the whole, whatever part of the program is kept in there. Okay, this should now be way better. Actually, we will actually do something else. Let's do 12 R equals RND 4. 13 K equals we're working backwards. We're doing it all over again, but we will have actually more space to do some stuff I want to do. So 14 if K equals 1, then ux equals, guess 1, 15 if k equals 2, then ux equals 2. 16 if k equals 3, then ux equals 3. 17, 18. We will run this again, make sure it works. Run. Okay. Okay, we do want, we do need, an extra thing again. See, this is why you work in like hundreds and stuff. I should have done that. 1, if k string equals 1, then ux equals 0. 15 if k string equals 2, then ux equals 1. 16 if k string equals 3, then ux equals 2. If k string equals 4, then ux equals 3. And 18 if k string equals 5, then ux is 4. This should, yeah. So you can pick which one you want to go to. So it's super easy for a quick action. 12 r equals actually r3. We are going to remove that extra component. So now it's just 1, 2, 3, 4, 5. There's nothing. Okay. We are actually going to combine some code since you can't really see. Now we've compacted it down. Now we will actually combine two things. At 225 plus ux. See if this works. 21. Print at oy plus or o at 25 plus ux. Nope. Okay. 20 print oy plus r print, actually do this. No, print, actually I don't know if we can do this. Print at 225 plus UX. So didn't really impact it down too much. But yeah. So this is a basic program that moves the things. Now we need to catch these. So 30, if OY, and we don't need the ats for this, plus R equals 225 plus UX, then 90. This is just going to line 31 if I guess OY plus R n equals, I guess, 225 plus UX and OY plus R equals 225 plus equals 225 plus R, then sound 124 2 S equals S minus 1. So hopefully this should be a code for failing sound 126 127 126, I don't know, 2 sound 223 229 239 219. Oh, 218 sounds good. Go to 81. Wait, let's try this. Oh, okay, that works. I do score. I know I spelled that wrong, but it doesn't really matter. Score equals. Oh, okay. We're gonna try to combine it as much as possible. Like Eastern. So now I have to rewrite it all over again. Step 32. I'm trying not to make 600 equals R&D 2 CLS K and key. And I have a code I actually could just removed and subbed in this, but okay, I don't need 19s since we are. Okay, this should be a pretty much fully functional game. Oh my god, I had 2 extra keys all along. Okay, I have, well, 1 extra keys. Interesting. Equals 0, 2, 2, 4, step 32. R equals RMD 3, CLS K string equals M key string. Hopefully this works. Send it. Oh, what am I? Hopefully I can see it. CLS. Huh? Oh, that's so simple. I couldn't see it for a second. No, 0, not O. 224. Step 32. So everything else is right though. So it's okay. Exactly how I did for CLS. K string goes in key string. Yeah. List. I'm just adding something in it, or it's like the best place to have things in since it's not gonna make any new lines or anything. See? Oh, oh, I just added a space. I don't really need to change that though. R equals RMD3 CLS. It's actually nice. Key string equals in key string sound for if S is less than 2, then we use this one. Okay, so this is our program. You can type it in and hope you enjoyed. Bye.